So let's talk a little bit about the parameters in a function. So what we can do is we can use something called a reference. And what that is, a reference is going to let you share information within the program without having to copy information over. The idea is kind of like this, if I could loan you like a book, for instance, and what I could do is I could be one of those people where I like my books nice and pristine, or maybe it's like a kind of fancy leather bound book or something. I could loan you a book and say, I'm going to give you this book, but you are not allowed to tamper with it in any way. Just look at it, don't mess with it. I could be a lot more easygoing and be like, hey, take this book. If you want to write in the margins, that's fine. If you want to rip out some pages, that's fine. If you want to make it dog-eared, whatever, you can take it, and then I don't care what you do with it. You can change it to your heart's content and even potentially destroy it, but that's your business, not mine. The third option is I want to give you the freedom to mess around with the book, but I also don't want to damage the original that I have. So what we could do is this would be in gross violation of copyright, but we could go to like a copy machine and like photocopy the entire book, and I could give you that, and then you could take all those pages, and you could fold them, you could write on them, you could dog ear them, whatever you want to do. And so in programming, those are essentially the three ways you can deal with data. You've probably encountered the term read only sometimes with certain files. That's the first situation I was describing where users have access to the data, but they do not have any kind of permission to change it. So I'm going to loan you my book, but God help you if you like write in the margin of my book. Fun fact, I had an English teacher who was all like, oh, when you read novels, you should like write stuff in the margins. But my dad, who's a hardcore bookworm, he thought that was like a travesty, and he was always like, "You never write in books." And it was he and my teacher like, and they were like often they were like his copies of the books too, because like he liked to pride himself. Be like, "Hey, I need this book for class," and then he'd like go downstairs and be like, "You mean this book?" I was like, "Oh, yeah, you're really cool there, Dad." But anyway, um, there was one. Oh, he was so embarrassed because he had Ethan Frome by Edith Wharton, but he did not have The Age of Innocence by Edith Wharton. I was like, take that, old man. Your collection is incomplete. He's like, why do you want to read Edith Wharton? So that's beside the point. Anyway, yeah, I told him about that, and he's like, yeah, that I don't know what you're gonna do, but you're not writing in my book. So anyway, where were we? So you can have read only where you're not letting people tamper with stuff. You can give people write access where they can overwrite files and change them. The potential downside to that is people could, for instance, I don't know, inadvertently destroy information that might be really important to like an organization, for instance. When I worked in the private sector, this is kind of a funny story. I had to be given write access, write as in like write stuff down. I had to be given write access to the database that I was needing to access for my job. And so this took a really long time, and there was this big rigmarole of like you had to put in an IT request ticket, and then they had to like process it, and they had to do all this stuff. And it was this big bureaucracy, and it took like several days to get me write access to do my jobs and access this database, because they didn't want me inadvertently destroying data of vital import to this company, because that's how they get them their money. And the funny thing that happened was my supervisor came over, and she was like at my computer with me, and she was getting so frustrated because the IT ticket said I had write access, and we were trying to write stuff to the database, and nothing was happening. and she was furious, and she was like this little bitty woman who was like 5 feet tall, and she would wear these absurdly huge heels. So she was like stomping in heels, which I've never seen done before. And it was a miracle she didn't fall over, but she was irritated. And the thing I thought was also absurd about this was that the IT people we were like making the request to, they were literally like 4 cubicles over. Like they were on the same floor in the entire building. Like it was like a 5-6 story building. They were just over there. And we had to do all this process of like filing a ticket and having them process it and doing all this stuff. And that was the thing I was kind of weird at. People thought I was weird at that company because I would like wander over to cubicles and start talking to people. And that's probably why I'm not a professional programmer anymore. But, you know, the secretary thought I was pretty sweet because I would like actually talk to her. But anyway, so she stomps over. She's in this little bitty woman in these heels. She stomps over and she's like, I thought you told me you resolved this IT ticket. Why does he not have write access? And the guy's like, lady, he does have write access. I did it myself. I even did it a second time this morning because you thought he didn't have write access. And she's like, well, something is wrong. Look at it. And he's like, look, it's right here. See, there's his name, Matt Husky. Here's his credentials. There's his login. And then he looks at it and he's like, oh, his cache is 0 megabytes, meaning I could write things, but I had no actual space on the database. I had 0 megabytes of space to actually put stuff. So he's like, oh, let me change that for you. And that fixed the problem. But anyway, so the joys of bureaucracy. But anyway, fun fact, I also told that story at like other private sector jobs I had, and no one seemed to find it as amusing as I did, like, because probably they had their own bureaucratic problems. That nobody seemed to think that was as funny as I did. But anyway. So you can have read-only access, you can have write access. Everything we've actually been doing up to now has been this third option, where when we've been doing stuff with functions and everything we've been doing in our programming up to now, it's actually been creating copies of the variables. And then it's actually sending a copy of like A, like we had a thing where it was doing int A, B, it was like averaging A, B, and C. What the compiler is actually doing behind the scenes is it's copying each one of those variables and then sending the copy to the compiler. So it's preserving the original data, and then it's creating copies, and then it's actually doing things to them with the copies. There are advantages to that because you're not going to inadvertently destroy data. The downside is, as you might imagine, if you think about, either I could loan you a book, or we could go to the copy machine in gross violation of copyright laws and take the time to Xerox the whole text of something ridiculous like Moby Dick, which is like huge. As you might imagine, in computer terms, making copies of things takes time, it takes processing power, and it will slow you down. So what we can do then is we could, like if we assign a variable like this, if we say int A equals 4, and then we have int B, and then we say B equals A. Basically, we're making a copy of A. So now there are 2 boxes in the computer's memory. When you define an int, it creates like a box to put the value. So there's a box somewhere that it's called A, that has a 4 in it. There's a different box B, which also happens to have a 4 in it. And it might seem a little redundant to you to say, well, why do we need 2 boxes that both have 4s in them? And I mean, nowadays, in an era where we have like gigabytes and even terabytes of storage, this is not as big of a deal as it used to be. But there is a quote from I think there was an IBM, I'd have to look up the quote. One of the IBM CEOs in like the 70s made some goofy comment like, I can't imagine people needing more than 1,056 megabytes of RAM or of memory. And that quote didn't age well, let's just say. But anyway, the point is, back in the day, anything you could do to reduce redundancy and improve performance was like a super big deal because of the limited capacity of the machines of the day. Now it's not as big of a deal, but it's still kind of a big deal when it comes to trying to speed up performance. Because like I was saying, this copying things will slow you down, and little by little, it can carry over and slow you down a lot. So we've got read-only forms, we've got editable forms. We can give or withhold permission to modify. And so the way you can do this, you can do what are called passing references. So most of the time when programmers use references, I mean, you can do it in other contexts too, but the most common way it's done is in function headers. So what is a reference? Well, in this case, it's not like somebody who's gonna tell like your employers how awesome you are, but those kind of references are kind of handy too. What we got? When we define a variable, we're gonna define it such as, for instance, int I, and we're gonna assign it a variable. So we could say like I equals 10. And so we've made a box, it's its own independent box, and in that box is a 10. And then what are we gonna do? We can pass a reference, and the way you do that is you put an ampersand after the variable type. So int and then you say j equals I. And so essentially what this is, instead of copying it, you basically have two different names for the exact same box. That's basically what this does. We've already got a box called I, which has a 10 in it. And we're just saying, hey, every time you see a J, just know that it's referring to that same box. So J is just a reference to that box of memory. I is the box where it's actually stored. And so we're basically making a new name for a box that we already have. Anything I do to J will affect the original box of memory. That's why this is kind of a big deal. So you could like change the reference and it'll change the original value in the box too. So here's something we could do, for instance. We got our typical like headers right here. We got int main. We're gonna set a equal to 1. And then we're gonna we're gonna create a reference. We're not passing by reference yet, but we're gonna create a reference. We're gonna say B is going to refer to A. So A and B really mean the same thing. Here we're going to output A, put a space, and then output B. And both of these will just show us a 1 because we set A to 1 and B just refers to the same box. If I change A to 2, when I output here, it's going to output a 2. And then since B just refers to that same box, if I change what's in the box, B is also going to be 2. But then here's the fun fact, and this is where this is kind of a big deal. If I change B, it's going to go back and also change A along with it. So it's just two different names for the same thing. If you change either one of them, it will change the stuff in the box. So running this program, we'll have 1, 1, 2, 2, 3, 3. And so big takeaway, we've created a reference. You have two names for the same box. If you change either one, it changes what's in the box. That's kind of the idea.